Welcome everyone to the third lecture. We're still in Module 1, Basics of Statistics, and today we're going to talk about frequency distributions. Up to this point, we have talked about the two general types of statistics. We have also talked about the importance of understanding your variables, so the characteristics of your variables. We've talked about operational definitions, the types of variables that you have, whether they're ratio, interval, ordinal, or nominal, and that's what RION stands for. Also, we've talked about reliability and validity of our variables. In addition to those, we need to talk about how our variables are distributed. So in other words, we need to know about the counts and the frequencies of the numbers that we collect. So let's just start off and let's look at this big block of numbers here that's in front of you on the screen. So there's about 1,300 numbers here. And let's assume that these numbers represent the number of minutes in the shower that people spend in the morning. And so if we look at this, we see that there's quite a bit of variability, but it's really hard to interpret. In fact, cognitively, we don't do well with a big mass of numbers. And so when we're talking about frequency distributions, what we want to do is we want to narrow down this mass of numbers into something that is manageable for us cognitively. So if we're just looking at it and if we're trying to find the lowest number and the highest number, it becomes very difficult to see it. And so I see at least one zero in this block of numbers, and I see some numbers in the 40, so maybe 43 minutes or 44, but it's really difficult to tell just how much time people as a whole are spending in the shower. But if I can shorten the information down, if I can compress it and categorize it in some way, then I can make it easier to interpret. And that's what frequency distributions are all about. So to help make data more interpretable, today we're going to talk about frequency tables, frequency graphs, and then also the normal distribution. So let's start with frequency tables. Frequency tables allows us to take a large set of information, such as 1,300 data points, and compress it down into a table that is easy to comprehend and understand. So in this table, we'll be able to get counts of values. We will also be able to turn those counts into percentages. And what this does is it allows us to see the shape of the values. And you see that shape and C are in parentheses, and that's because we actually aren't going to draw anything with a table as far as a shape, but we will be able to see which values are most common and which values are least common, and that'll help us understand the data set that we have. Now there's two types of frequency tables, one with units or single values, what we call discrete values, and others with intervals of values or ranges of values. The standard frequency table is used when we have fewer values. So these might be cases where we have maybe a response scale or we have a small range of values, usually less than 10 digits. In most of these cases, the values are whole numbers, but it doesn't necessarily have to be the case. What really matters is how many values do you have, and if it's less than 10, you're probably going to use a standard frequency table. Now the other table is the group frequency table, and this is when you have a wide range of values. And so you still want to be able to condense the information down into something that's manageable, and so what you end up doing is you end up creating ranges, or we call intervals, of values. So again, used when we have a wide range of values, something like yearly income. If we're asked people about their yearly income, it would vary quite a bit from person to person. Some people may only report making maybe $17,000 a year, and some will report making $200,000 a year. So we have this very wide range of values, and everyone in between them. And so it wouldn't make sense to get a count for every single possible value. So we might group values together, like 15,000 to 25,000, 25,000 to 40,000, so on and so forth, to make it easier to understand. Now, group frequency tables typically includes decimals, but it doesn't necessarily have to. And so if we have a lot of decimals, we probably want to do a group frequency table. Now when we're creating group frequency tables with large sets of data, we typically want to reduce those data to between 7 and 10 intervals. And there's a reason for this. If you have taken a psychology course, you probably would remember this, but there's a concept called Miller's Magic 7. And Miller's Magic 7 says that cognitively, we can only handle 7 bits of information plus or minus 2. So anywhere between 5 and 9 bits or chunks of information. And so when we're creating group frequency tables, we want to follow our cognitive limitations and fall within that range of 5 to 9. And so typically you'll see somewhere between 7 and 10. You don't usually see 5 because then it's hard to gauge a normal distribution, which we'll talk about later today. And you don't want to go over 10 because then it's just too cognitively tasking and it's hard for us to interpret the information or the data. Now let's create a frequency table together. Now we won't do a standard frequency table, we'll go ahead and do a group frequency table. The reason why is the group frequency table is the more difficult of the two, and the steps you use for the group frequency table apply directly to the standard frequency table, and so there's no reason to do both of them. It'd be twice the work. So let's start with the group frequency table, and let's go ahead and create one together. Let's assume that we're interested in studying juvenile delinquency. So juvenile delinquents are minors who have committed crimes. And so it might be interesting to know if these minors who have committed crimes have a history of discipline problems in their schools. And so we may want to get a count of the number of disciplinary issues that they've had in the last 4 years of school. And so here's our data set, and we see we have several juveniles here, and next to each of these juveniles is a number, and that number represents the number of school discipline issues or the acts of discipline in the last 4 years. There are several steps to creating a group frequency table. I don't necessarily think you need to memorize these steps because I think once you do a couple tables then you'll pretty much know what you need to include, but it is helpful to go through them for the first time. So the very first step is to take your values and order them from the lowest value to the highest value. Now if you order them from highest to lowest, that would work as well. I just find it easier to go from lowest to highest. So here is our data reordered. You'll notice that just by reordering it from lowest to highest makes the data just a little bit more interpretable. In fact, you can see that the lowest number of acts of school discipline is 8 by Michelle, and the highest is Julia, and she has 22 acts of school discipline. So that right there allows us to create some sort of range to get an idea of where the values are falling between. We also note just by looking at the order that it looks like there's several juveniles who have 14 acts of school discipline and some that have 16 and 13. So anyway, just by reordering the data, it starts to make a little bit more sense. Now once we've reordered our values from lowest to highest, we then want to find the full range of the data. So note that full range is different than range, and you'll be asked for both the range and the full range. The range just gives us a difference of the highest value minus the lowest value. So it tells us the values in between the highest and lowest. Whereas the full range is inclusive of all values. So we'll take the highest minus the lowest and then we'll add something. Now that something is usually 1, but what we add will depend on the data set itself and what types of values that we're dealing with. So you're probably wondering why we're adding 1 to our range. So let's go through an example, and this might clarify it a little bit. So let's say we have 3 numbers, and those numbers are 2, 3, and 4. So we have 3 values, and so we'll keep this fairly simple. And let's say I wanted to know the range. And so to know the range, I would take the highest value, 4, and I'd subtract the lowest value, 2. And that would give me a range of 2. But the problem is there are 3 numbers in my data set. Right? Values of 2, a value of 3, and a value of 4. And so the range of 2 is not going to be inclusive of all 3 of my numbers. So I need to add something to my range. And so in this case, we might add 1. And 1 would make sense because the numbers 2, 3, and 4 are in single digits, and so that would cover our numbers. So if we did that, we would take the highest, 4, minus the lowest, 2, and we add 1, and then we would get 3 for our full range. And so now we can be completely inclusive of all of our values. So in order to be inclusive, we have to add something to our range in order to get the full range. In this case, it needs to be relative to the values in your data set. So let's say we had decimal places. Let's say we had 0.2, 0.3, and 0.4. Well, it wouldn't make much sense to add 1 here because our range would be way too wide or way too large. Because we're dealing with decimals and then we're adding these whole numbers. And so it would probably make more sense in that case to add 0.1 instead of 1. And so we take 0.4 minus 0.2, add 0.1, and we get a full range of 0.3. And that would work to our advantage, and that would be better. The same thing if we had hundreds, so 200, 300, 400, it might make sense to add 100. So in all those cases, we have to look at our data set, we have to look at the measurement itself, the unit of measurement, and decide what would be best to add to our range. Typically it would be 1, but not always. You should be prepared to use different numbers if it makes more sense. So there's no hard and fast rule, but if you look at your numbers, determine what might be best to add to your range to get your full range. You'll know really quickly if it's not going to work, because when you start to create your table, you won't meet all the criteria, and we'll talk about those criteria here in a little bit. Let's go back and look at our data set, and we'll see that the highest value again is Julia with 22 and Michelle with 8 acts of school discipline. So we can take 22, we subtract 8, we need to add something, so let's go ahead and add 1. 1 seems to make the most sense here because we're dealing with single digits and the values are pretty small. We're not dealing with decimals, we're not dealing with values in hundreds or thousands, and so it probably makes sense just to add 1 to our range. And so we end up with 22 minus 8 plus 1, and that gives us 15. So 15 will be our full range. Once we have found the full range of the data, we then need to determine the number and size of the intervals. In other words, how many intervals do we want, and what's going to be the width or the size of each of those intervals. So we have a full range of 15, so our intervals need to cover 15 values in this particular case. The easiest way to do this is to take your number of intervals and divide it into 15. So if I'm going to have between 7 and 10, I probably want to pick the number of intervals that's going to divide the easiest into my full range. So 7 is probably not going to divide into 15 very well, neither is 8 and neither is 9. So maybe I'll go with 10 intervals. So I'll take 10, I'll divide it by 15, and that'll tell me that each interval will be 1.5 values wide. So I'll have 10 intervals, each of a full range of 1.5. We've determined the size of our intervals. It's going to be 1.5. We're going to have 10 of these intervals of 1.5 values each. So now we need to determine the lowest interval range. So what interval are we going to start with, and what's going to be included in that particular interval? That lowest interval needs to include the lowest value. The easiest way to do this is to start with your lowest value and then add your interval size. But you don't have to start with your lowest value. Just remember that that very first interval should include the lowest value, but it doesn't have to start at that lowest value. So if you remember from our data set, the lowest value we had in there was 8, and that represented Michelle's 8 acts of school discipline. And so we could start there. We can take 8, and we can add our interval range of 1.5. Now that would give us 9.5. And so what 9.5 would represent is the beginning of the next interval. So our lowest interval will end right before 9.5. And so we could say that our first interval, or the lowest interval, will range from values of 8 to 9.49. And of course that last 9 is repeating, so we could say 9.499999 just right before 9.5, because 9.5 begins the next interval range. Once we have that very first interval range, then we can go ahead and create a table. So we'll put 3 columns in this table. We'll have one column for intervals, another column for frequency, and then that last column or third column for percent of total. In other words, the percent that the interval represents of the original data set. Once we have those 3 columns, we can now list all of our intervals, so the full ranges of all of our intervals. So in this case, we're going to have 10 intervals. We already know our first interval. We just calculated that to be between 8 and values of 9.49. So we'll continue from there and fill in the rest of the 9 intervals. The important thing to remember is that the very first interval and the very last interval must contain values in our data set. So we should not have frequencies of 0 in the first and the last intervals. So here we are. Here's all of our intervals. So remember that very first interval was an interval of 8 to 9.4. our next interval begins at 9.5. So notice that our interval range was 1.5, and so if we take 8 and we add 1.5, we get 9.5. That's the beginning of the next interval. If we add 1.5 again, we get 11. That's the beginning of the third interval. So we can continue to do that, so on and so forth, till we go all the way down all of our intervals. We can then create each of the intervals, so we have 10 intervals, and we can represent all of our values. So remember, the very first and the very last interval must contain values. We can't have a frequency of 0. So we can check that. So our very first interval goes from 8 to 9.4. Our lowest number is 8. That does fall within that first interval. And then the last interval goes from 21.5 to 22.9. The highest number in our data set is 22, and that falls within that last interval as well. And so we don't want to have intervals that don't have any values when they're the first or the last interval. We can have intervals in between the first and the last that have frequencies of 0, but we can't have the very first or the very last interval have frequencies of 0. Otherwise, they're not needed and they shouldn't be in our table. Once we have listed the full range of all of our intervals, we can then go back to our original data set and count the number of values that fall within each of those intervals. Our first interval ranged from 8 to 9.49, and so looking at our data set, we see that we have 3 values between 8 and 9.49. So we have Michelle, who has 8, we have Rachel, who has 9, and we have Rebecca, who has 9. So we have a frequency of 3. In other words, we have 3 values within that range of 8 to 9.49. Now in the frequency column, we can go ahead and place a number of 3 that represents the number of values in our data set that falls within that very first interval between 8 and 9.49. So now we can continue through the rest of our data set and look for the number of values that fall within each of these particular intervals. And so if we go through our entire data set, we'll see that there's 3 within the first interval, 1 value between 9.5 and 10.99, 3 values between 11 and 12.49, and so on and so forth. Once we have the frequencies all written down in our table, we can then move on to the third column and calculate the percent of the values within each of the intervals. To calculate the percent of the values contained within each of the intervals, we need to know the frequency for each of those intervals, and we need to know the total number of values. So the total number of values is quite simply the number of juveniles that are in our data set. So we have 24 juveniles. Each juvenile has a value with the number of school discipline acts in the past 4 years. And so there's 24 juveniles, and so we'll divide each frequency for each of the intervals by the total number of juveniles. In other words, we'll take 3 for the very first interval and divide it by 24, and we end up with 12.5%. We'll take the next interval of 1 and we'll divide that by 24, and we get 4.17%, and so on and so forth all the way down our table. Now, if you don't want to go back and count all of the observations that are in your data set, or in this case all of the juveniles, you can also come up with the total number of juveniles by simply adding their frequencies together. So 3 plus 1 plus 3 plus 3 plus 8 plus 3 plus 1 plus 1 plus 1 equals 24. And you can also get the total number of values, or the total frequency, in order to get your percents that way as well. So either way will work. Either you can go back and count the total number of observations in your data set, or add up your frequencies in the frequency column, and you'll get the correct number of values to divide by. Now, like I mentioned at the beginning of creating group frequency tables, I said that memorizing all the steps probably isn't necessary. I think it's helpful to go through them at least the first few times so you make sure you know what's included step by step. But after you do a few, you have a pretty good idea of what you need to include in the table. There's 5 things that I'm looking for with your table. So note, depending on where you start your intervals, your table may look very different than another student's in the class. So there's not necessarily a correct table, but there are 5 principles that I'm looking for when I grade. So the very first one is that there should be between 7 and 10 intervals. So there shouldn't be less than 7, and there shouldn't be more than 10 intervals. So make sure you have between 7 and 10 intervals. there should also be a frequency count, a numerical count, in the first and the last interval. So remember, there shouldn't be a 0 for your frequency in the first or the last interval. I'm also looking for equal interval widths, and so your intervals should be the same width. And so when we calculated the interval ranges, we got 1.5. Well, each interval range should be 1.5 units wide, and it shouldn't vary as you go through each of your intervals, so it should all be the same. And of course, I'm looking for the correct frequencies given your intervals and the correct percents given your intervals as well. And if you cover all 5 of those things in your table, then you'll get full credit for your frequency tables, your group frequency tables, or your standard frequency tables. So finally, just a reminder, the whole purpose of frequency tables is to provide counts of our values, to also get percentages, so that we can easier understand the data set that we have. And when we have too many numbers, it's too cognitively tasking for us, and so we want to simplify it, and we can do that using frequency tables.